Okay, hi folks. Welcome back to Physics with Captain Rod. I'm making this one to help you out with number 12 in your homework. So let's see, calculate electrical costs for each case below, assuming 16 cents per kilowatt hour. So again, you're charged in electrical use by this quantity called a kilowatt hour. Just a little reminder here. So power is energy transfer over time. So if you just rearrange that, right, anything that is a power times a time is a unit of energy. So for example, if you took 6 horsepower multiplied by 2 minutes or something, you would get a number, 12 horsepower minutes. Kind of a bizarro unit, but it is in fact an energy unit. So the kilowatt hour is the standard energy unit that you are charged by. And my typical electric bills right now are running around 16 cents per kilowatt hour. So this number right here, this 1200 watts, that's 1.2 kilowatt. And this is for 5 minutes. If you convert that to hours and then multiply this times 5 minutes in hours, you would get a number with units of kilowatt hours. Then you just use this as a conversion factor. Part B, let's see, 5 60-watt bulbs for 6 hours a day for 30 days. So if we have 5 of these, they're running at the same time. Shouldn't be too hard to see. Your total power there would be 300 watts. Right? Convert that to kilowatts. And then just figure out how many total hours here we're talking about. Multiply the two, and then you'll have a number with units of kilowatt hours. That's the big thing you're looking for, kilowatt hour. And then you can apply your 16 cents per kilowatt hour. C, let's see, 50 gallons of water from 55 to 190 C. Remember, specific heat of water is 4186 joule per kilogram degree centigrade. All right, you're going to have to look up or figure out how many kilograms 50 gallons of water is. You're going to want to convert these to degrees centigrade. And from physics 1, remember heat transfer, you've got Q, which represents heat, is equal to mc delta T. So the mass, ultimately, you're going to get that from the 50 gallons of water. The delta T, you're going to get that from here, but it's got to be converted into degrees centigrade. And then the specific heat of water, right? Here's your 4186 joules per kilogram degree centigrade. You're going to get a number out of this in joules. Now, remember the 16 cents per kilowatt hour? You can convert kilowatt hours back to joules, using the following, right? So 1 kilowatt hour is, kilo means 1,000. Watt is a joule per second, and an hour is 3,600 seconds. So this comes out to 3.6 million joules. 3.6 times 10 to the 6 joules is equal to 1 kilowatt hour. So after you calculate how much heat is needed or how much heat transfer is needed to raise that 50 gallons up in temperature, then what you can do is convert that to kilowatt hours using this, and then the 16 cents per kilowatt hour. So I think I'm just going to leave that A, B, and C. If you have trouble with D, ask. I'll be happy to help you out with it. I hope that this helps. Have a great day.